Friends, welcome you all again back to Venkat Varma Chemistry YouTube channel. I hope all are doing well. In this session, I am going to discuss introduction about alkenes and methods of preparation of alkenes. In this session, I am going to discuss methods of preparation of alkenes and introduction about alkenes. Let's start our session. Alkenes. See, have a look for alkenes. See, alkenes, generally alkenes are saturated hydrocarbons. Alkenes are saturated hydrocarbons. Saturated hydrocarbons. What it means, saturated hydrocarbons? They have carbon-carbon single bonded. Carbon-carbon having the single bond. The saturated hydrocarbons are alkanes. Alkanes also known as paraffins. Alkanes also known as paraffins. What it means, paraffins? Param means little. Affinis, it means affinity. These are less reactive. Alkenes are less reactive towards chemical reaction. Alkenes are less reactive towards chemical reaction. Why alkenes are less reactive? Due to a strong CH bond. Due to strong CH bond. And carbon-carbon single bond, and non-polar nature of CH bond. That is a reason for alkenes are less reactive towards chemical reactions. See, what is a general formula for alkenes? Have a look for general formula for alkane. See, alkane general formula, its general formula is CnH2n plus 2. N equal to number of carbons. N equal to number of carbons. Generally, carbon-carbon, its bond length will be 1.54 angstroms. Carbon-carbon single bond, its bond length is 1.54 angstroms. And carbon-hydrogen, its bond length equal to 1.09 angstroms. Its bond energy, have a look for bond energy. The bond energy, it is nearly 415 kilojoules per mole. See, carbon-carbon single bond, its hybridization is sp3. Hybridization is sp3. Its shape is tetrahedral. So in sp3, the percentage of the s character equal to 25%. It is a 25% of s character in sp3 hybridization. This is for introduction about alkenes. Have a look for once again for alkenes. Alkenes are paraffins. Paraffins means less reactive. It means less reactive. Param means little. Affinis means affinity. Little affinity. These are less reactive towards chemical reactions. What is the reason? What is the reason? Due to it has strong CH bond and carbon-carbon single bond and non-polar nature of CH bond. Non-polar nature of CH bond. See, general formula for alkenes CnH2n plus 2. N stands for number of carbons. Carbon-carbon bond length is 1.54 angstroms. See, carbon, hydrogen, its bond length is 1.09 angstroms. Its bond energy is 415 kilojoules per mole. Its hybridization is tetrahedral. Tetrahedral means its percentage of the S character is 25 percentage. 25 percentage. See, have a look for methods of preparation of alkenes. Have a look for methods of preparation of alkenes. See, methods of preparation of alkenes. See, method for preparation of alkenes. Of preparation of alkenes from hydrogenation of alkenes and alkanes. See, from hydrogenation of hydrogenation of alkenes and alkynes. Hydrogenation of alkenes and alkynes. See, it is also known as hydrogenation of unsaturated hydrocarbon. Hydrogenation of unsaturated hydrocarbons. See, have a look for methods of preparation of alkanes. See, hydrogenation of alkenes and alkynes. See, what is mean by hydrogenation? What is mean by hydrogenation? What is mean by hydrogenation? Hydrogenation means addition of hydrogen. See, addition of H2 hydrogen to carbon carbon double bond or carbon carbon triple bond means unsaturated carbons. Addition of hydrogen to unsaturated carbon carbon double bond, sorry, unsaturated means carbon carbon double bond or triple bond. See, have a look for reagent. Which reagent is used for the hydrogenation? What type of reagent is used in hydrogenation? See, have a look for reagent. Reagent is H2 catalyst, hydrogen and a catalyst. What is the catalyst? What is a catalyst? What is a catalyst? Catalyst is nickel or platinum or palladium metal. Nickel or platinum or palladium metal. This reaction is example for syn addition. See, this reaction is example of syn addition. Syn addition. Syn addition. Now, this reaction takes place through four-member cyclic transition state. See, this reaction is takes place. See, this reaction is takes place. This reaction is takes place takes place four-membered cyclic transition state. Four-member cyclic transition state. What it means? Four-member cyclic transition state. Have a look for mechanism. Have a look for mechanism. See, if what type of catalyst is used? Nickel. See, see. For example, it is a surface of nickel. Surface of nickel. See the surface of nickel. See, in the nickel surface, H2 is adsorbed on the surface of the metal. H2 adsorbed on nickel surface. Nickel surface. See, then carbon carbon double bonded. Carbon carbon double bonded. Double bonded. See, one is sigma, other one is pi bond. See, the breaking of sigma bond, the breaking of sigma bond can, the hydrogen is attached. The hydrogenous, the breaking of this hydrogen bond and this carbon bond breaking, the bond formed between carbon 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 with the hydrogen, carbon with hydrogen. See, have a look for the reaction. See, this is the carbon carbon already present in the hydrogen, present in the hydrogen. See, this hydrogen, these two hydrogens, this two hydrogen is adsorbed on the metal surface, is attached with carbon 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 carbon. It is a surface of metal, surface of metal. See, have a look for this. See, the bond formed. See, four-member cyclic transition state. See, 1, 2, 3, 4. It is a four-membered cyclic transition state. Four-membered cyclic transition state. See, we get what? We get carbon carbon single bond. Carbon carbon single bond. Carbon carbon single bond. This is a alkene. This is the alkene. This is a mechanism of hydrogenation of alkenes with nickel metal. Nickel metal. For examples, I will look for example. See, CH2 double bond CH2 with hydrogenation with nickel or platinum or palladium metal. Palladium metal. What is the temperature is used? Temperature is nearly 200 degrees Celsius. 200 degrees Celsius or 200 to 300 degrees Celsius. To the pi bond is breaking of pi bond attached with the hydrogens. Attached with the hydrogen, it forms alkane, means methane. So we are using the 1 mole of hydrogen. 1 mole of hydrogen is used in alkene to alkane. See, have a look for next example. CH double bond CH or with hydrogenation. So the same reaction for nickel or platinum or palladium metal at 200 to 300 degrees Celsius, it gives alkane. It gives alkane. See, the breaking of pi bond, attaching of hydrogen with carbon. See, have a look for next example. See, carbon 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 with triple bond. Carbon carbon with triple bond with hydrogenation. Hydrogenation. Same environment. Nickel at 200 to 300 degrees Celsius, it gives ethane. It gives methane. So we need how many moles? 2 moles of hydrogen is needed. 2 moles of hydrogen is needed for alkyne to alkyne to alkane, alkyne to alkane. Have a look for example. See, R C triple bond C, or with hydrogenation, how many moles? 2 moles. It's convert alkane, or this is for alkane. Have a look for some more examples. See, CH3, CH double bond, CH2 with hydrogenation with nickel at 200 to 300 degrees Celsius. It gives what? Alkane, CH3, CH2, CH3. Have a look for next example. CH3, C triple bond C. We need 2 moles of hydrogen. It gives CH3, CH2, CH3. Have a look for next example. See, CH double bond CH2 hydrogenation at nickel 200 to 300 degrees Celsius. It gives CH2 CH3. Have a look for next example. See, have a look for next example. We need 2 moles of hydrogen in presence of same environment. It gives have a look for next example. See, for example, cyclopropane. Cyclopropane with H2 H2 at nickel catalyst. Nickel catalyst. What is a product for this reaction? See, generally cycloalkanes also reduced to alkanes involving the cleavage of carbon bond. So cleavage or breaking of bond, which minimize the strain. It gives propane CH3, CH2, CH3. Generally, cyclobutane has strain. So it has strain. So the breaking of bond with a hydrogen at a nickel catalyst, it gives CH3, CH2, CH2, CH3, CH3. It is a cyclobutane to butane. It is a cyclopropane. So it is a cyclopropane to propane. It is a cyclobutane to butane. Cyclobutane to butane. See, cyclobutane has highest strain. So it becomes alkanes in presence of hydrogen and nickel. See, have a look for if cyclopentane is present with the hydrogenation with the nickel catalyst or platinum or palladium catalyst. What is the product? What happened in this reaction? It's no reaction. It is a no reaction. What is the reason behind it? They are stable. The cyclopropane and cyclohexane also, they have stable, so there is no reaction with hydrogen with a nickel catalyst. No reaction. So which is already stable, it does not react with hydrogen with nickel. hydrogen with nickel. See, for question C. In presence of H2 in one equivalent nickel heated, what is the product? Here two double bonds are there. We have only one equivalent. We have one equivalent. So how to write this product? See, generally stability is stability is inversely proportional to reactivity. Stability is inversely proportional to reactivity. Have a look for, so this carbon carbon double bond, it undergoes sp2 hybridization. So sp2 carbon with this carbon is sp3 carbon. Sp3 carbon is a alpha carbon. sp3 carbon is a alpha carbon. See, have a look for this carbon double bonded attached with carbon is a sp3 carbon. This is the sp3 carbon. So it has how many hydrogens? Two alpha hydrogens. It has two alpha hydrogens. So have a look for this carbon has three hydrogen. This carbon has three hydrogen. It has six alpha hydrogen. Six alpha hydrogen. Alkene stability decided by using hyperconjugation by using alpha hydrogen. So this carbon has two alpha hydrogen. This carbon has six alpha hydrogen. So which is stable? So six alpha hydrogens are more stable. More stable means least reactive. Least reactive. So it is a less stable. Less stable means more reactive. Less stable means more reactive. So this one equivalent of hydrogen attacks over this carbon carbon double bond. So I am writing the product. See, have a look. This is the product. This is the product. I will look for next question. I will look for next question. See. So C triple bond C H C H double bond CH2. Here also one equivalent of hydrogen at nickel metal. What is a product? What is a product? So generally carbon carbon triple bond is more reactive than double bond. See, carbon carbon triple bond is more reactive than double bond. So obviously this pi bond is breaking of pi bond. So attacking of hydrogen means CH2 double bond CH, sorry, see, have a look for this question. Have a look for this question. See, carbon carbon triple bond with in presence of H2 in palladium in calcium carbonate or quinoline. What is a product? So hydrogen palladium calcium carbonate is a Lindlar's catalyst. It is a Lindlar's catalyst. It is a Lindlar's catalyst. It gives a alkene. What type of alkene is formed? It forms cis alkene. Cis alkene. Cis alkene. See, alkyne with hydrogen with palladium, calcium carbonate, quinoline. It gives a cis alkene. It is a syn addition. It is a syn addition. Syn addition. See, have a look for this. Please remind this important concept. See, carbon double bonded CH3, CH3, C2H5, C2H5 in presence of hydrogen catalyst and palladium acetic acid. What is a product? So it is a what alkene? Cis alkene. Cis alkene, hydrogen with palladium. What attack? What addition? It is a syn addition. Syn addition means what is our product? Product is a meso. So this is a Fischer structure. C C2H5, C2H5. It is a CH3H and CH3H. It is a meso product. It is a meso product. CSM. CSM. See, have a look for next example. Carbon carbon double bonded with trans alkene CH3 CH3. So C2H5 and C2H5. See, in presence of H2 with palladium metal. Palladium metal. It is a trans alkene. Trans alkene with syn addition. Syn addition. Trans alkene with syn addition. TSR means it gives racemic mixture. It gives racemic mixture. See, I will look for product C2H5. It is CH3H and CH3. Sorry, it is a hydrogen C. It is a CH, C2H5 and C2H5 is a H CH3. It is a CH3. It is a H. It is a racemic mixture. It is a racemic mixture. It means what as TSR. 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 See. I will look for next. See, the best catalyst known for the hydrogenation is Wilkinson catalyst. The Wilkinson catalyst is a triphenyl phosphine chlororhodium. This is a Wilkinson catalyst. See, Wilkinson catalyst. See, the triphenyl phosphine coordinate covalent bond with the rhodium is one coordinate covalent bond with rhodium, coordinate covalent bond with rhodium, and coordinate covalent bond with rhodium. See, in this Wilkinson catalyst is a homogeneous catalytic hydrogenation. It is a homogeneous catalytic hydrogenation. What it means by homogeneous catalyst? In this homogeneous catalyst means the reactant and the catalyst has same physical state. The reactant and catalyst has same physical state is the homogeneous catalytic reactions. Homolytic catalytic reactions. We will look for Sabatier-Sandrens reaction. Sabatier-Sandrens reaction. In short, SSR. The hydrogenation of unsaturated hydrocarbons using ordinary nickel at a temperature about 523 to 573 Kelvin is known as Sabatier-Sandrens reaction. For example, unsaturated means carbon-carbon double bonded or carbon-carbon triple bonded with nickel at 523 to 573 Kelvin temperature. Those reaction is known as Sabatier-Sandrens reaction. Sabatier-Sandrens reaction. With unsaturated hydrocarbon nickel at ordinary temperature, about using ordinary nickel at temperature about 523 to 573 Kelvin is known as Sabatier-Sandrens reaction. See. See, here using Rani nickel also, using Rani nickel. See what it means, Rani nickel. So Rani nickel means it is a aluminium nickel alloy. Aluminium and a nickel alloy with a concentrated of sodium hydroxide. Sodium hydroxide is a Rani nickel. So aluminium with the sodium hydroxide, it gives NaAlO2 with a release hydrogen gas. It is a strong reducing agent. It is strong reducing agent. It is a strong reducing agent. See, have a look for questions. See, which of the following alkenes cannot prepared by Sabatier-Sandrens reaction? See, methane is there, neopentane is there, or both or neohexane. See, which of the following alkanes cannot prepared? So, methane cannot prepared by using Sabatier-Sandrens reaction. So, CH4 not prepared Sabatier-Sandrens reaction. Here also neopentane also cannot prepared by using Sabatier-Sandrens reaction. Our option is C. Option is C. Have a look for next question. Which of the following alkenes is more reactive in Sabatier-Sandrens reaction? Which of the following alkenes are more reactive in Sabatier-Sandrens reaction? See, CH2 double bond CH2. It is a ethene. It is a propene. It is a butene. Okay. See, have a look for hint. It is a metal surface addition reaction. It is a metal surface addition reaction. Metal surface addition reaction. It means hydrogenation reaction is a metal surface addition reaction. In metal surface addition reaction, crowding groups or bulky groups are present. Addition is slowly taking place. See, so it has two groups. Okay, it has 1, 2, 3, 4 groups. It has one group. So crowding groups. See, crowding groups are bulky groups present addition is slowly takes place. What is our option? See, which is our option? The first one is our option. See, I will look for next question. See, it is a cyclohexene hydrogenation. Cyclohexene hydrogenation. Which addition It is a syn addition. Syn addition. See, have a look for this is a hydrogen. This is a hydrogen. See, so addition with the hydrogen with cyclohexene, it gives, see, in addition, same side attacks, same side attacks. So our option is C and D. C and D. I will look for next question. Hydrogenation with nickel heating, it gives 1 to 2 methyl, 2 methyl butane, 2 methyl butane is, so which is a reactant, which is a reactant. If addition with a hydrogen in presence of nickel, it gives what? Same, 2 methyl butane. If addition with nickel, it gives what? 2 methyl butane. See, addition with hydrogen, it gives what? 2 methyl butane. So our option is all. Answer is E. I will look for next question. See, which double bonds are more reactive in catalytic hydrogenation? So it is CH double bond CH2. It is a cyclic in form. Which double bond? And A, B, C is there, which is more reactive. See, less substituted, more reactive. See, less substituted, reactive. Less substituted is more reactive. See, A. After that, C. After that, B. Less substituted, more reactive. Aliphatic is more reactive than aromatic. Aliphatic is more reactive than aromatic. This is for hydrogenation of alkenes and alkynes. Like this video, don't forget to share your friends. Don't forget to give like. If you find this content valuable, make sure to subscribe for insightful lecture. Thanks for watching.